All right, hello everybody. Let's continue our journey of precalc. For this lesson, we are going to analyze graphs with the notion of what does it mean for the graph to increase, decrease, the domain, and the range. So let's begin. Let's have this in our notes here. Let us study functions in a visual and a graphical sense. The graph of a function f is the collection of ordered pairs x, comma f of x, or this is my x values, f of x are my y values, such that x is in the domain of f. So we'll talk about domain if we're not too comfortable with this terminology, but just the idea that for any function of f, if we have, let's say this is our function over here, our x value would be directed, it would be the distance from the y-axis. So let's say if this is my x value, let's say this is a, right? So then the distance of a would be from here to here, and the distance of f of x would be whatever this f value is, whatever this y value is, it'd be this distance here. Okay, pretty straightforward, right? All right, so here, what does it mean for a function to be increasing, decreasing, and what does it mean to be constant? So before we actually begin, do me a favor, have this in your notes, right? Be patient and please pause the video and just have this down. And then also have this part down over here for constant, right? So let's go over each, right? So let's say you copy this in your notes. Let's go over each idea. So here it's saying a function f is increasing on an interval if for any x sub 1 and x sub 2 in the interval, x sub 1 is less than x sub 2 implies f of x sub 1 is less than f of x sub 2. So what on earth are we talking about here? Just to make a, because the definition is one thing, a picture always makes your life much easier. So here, if I have, let's say, so for a function that is increasing, we always look left to right. Here, for this point x sub 1 and for this point x sub 2, notice x sub 1 is less than x sub 2, and also that the y value, right, this is f of x sub 1, and this is f of x sub 2. We know that x sub 1 is less than x sub 2. So then the graph must be increasing from this part of the domain, from x sub 1 to x sub 2. For here, we know that x sub 1 is less than x sub 2, but this time our x sub 1 value, our f of x sub 1 value over here, this is f of x sub 1, and this is f of x sub 2. Here, notice that this f of x sub 1 is greater. So even if we don't have the picture, I would know that the graph is decreasing between x sub 1 and x sub 2 because I know that the y value for x sub 1 is larger than the y value of x sub 2. Okay? A little dry, but this is the correct terminology. And notice that here, what is happening in this diagram, here our x sub 1 is less than, is less than x sub 2. But the most important thing is that our f of x sub 1 is equal to f of x sub 2. So then here the idea that there's no slope, and here that the graph is neither increasing or decreasing from left to right. If I know that this part is true, then the graph or the function is constant between x sub 1 and x sub 2. Okay, even hearing myself say that, it felt a little bit boring, but here is the correct terminology, right? The idea, the next part of the lesson here, and I'm guessing this lesson is going to be very short, the idea of domain and range. To make your life very easy, when we think of domain, think left to right, and then, or maybe even, you could even say how far left, how far right. And for range, you could say how far low to how far high. Okay. So when we talk about domain, we're talking about all possible x values. our input values. For range, we're talking about all possible y values or output values. So do me a favor, just have this terminology in your mind for a second. What we'll do is we will look at some examples. Examples are always nice to go over certain ideas. So here, let's take a look at this graph, or look at these graphs. And what I'd like you to do is first, please have it in your notes, right, before. So when you watch the video, it'll be nice and smooth. Please create this visual, this one, and this one. Okay, and now here, let's say you have it in your notes. What am I asking us to do here? Find the domain and range for each function. Describe where the graph is increasing and decreasing, or maybe whether the graph is constant for certain intervals within the function, right? So take your time. For this function x cubed, what is the domain of this graph? Let's think about it. What is the domain of this graph, and how would we show it? So let me zoom in. Let me get a good camera angle. Okay, this looks good. So when we think of domain, think how far left can I go, how far right can I go? So you always start on the left side. So notice that for this function, even though it looks kind of like this, the idea is that all my possible x values are from negative infinity to positive infinity. So the way we could describe the domain is just like this. Meaning that I can plug in any x value from negative infinity to positive infinity for this graph of x cubed. I could plug in any x value. And notice that if I could plug in any x value, I could also receive any y value from negative infinity to positive infinity. There are no holes within the graph or any discontinuities. You have, domain is all real numbers, right? And that is and how should I show all real numbers? What would be the set notation, right? This is my set, right, for the domain of this graph. What would be the range for this graph? Same idea. From negative infinity to positive infinity, and basically the range is all real numbers as well. Okay. So how can we talk about whether the graph is increasing or decreasing? So how would you describe what is happening from negative infinity, from x negative infinity to x positive infinity? What can we say is happening? Okay, let's see. So the graph is increasing from negative infinity to positive infinity. Oh, sorry, the visual. The graph is increasing from negative infinity to positive infinity, because here my f of x of 1 values are here, and they're constantly increasing. Okay. Let's try another one. Here, how would you describe the domain for this graph? And what is the range? And how would show the parts where it's increasing and decreasing, right? Pause the video and try and go through it yourself. So let's see, the domain of this graph will also be negative infinity to positive infinity. The range is also negative infinity to positive infinity, right? I have all my x values from left to right, and I have all my y values from bottom to top, right? So from negative infinity to positive infinity. And what can we say about starting from negative infinity, right? So from negative infinity of my x value, right? From negative infinity to negative 1, because this x value over here is negative 1, you could say from negative infinity to negative 1, the graph is increasing. Right? Then what? From negative 1 to positive 1, so from here to here, the graph is decreasing. Right? The graph is decreasing from -1 to +1, and then from +1 to infinity, so from 1 to infinity, the graph is increasing. Okay? Let's take a look at this one over here. Try and describe the domain, the range, and for what part of the domain is the graph increasing, decreasing, and then, and increasing, right? So yeah, so pause the video and try and go through that yourself. So let's see, what is the domain of this function? Notice that how far left can I go? My farthest x value to the left side is a, and notice how I'm putting a parentheses here because do I have x equals a? I don't. You don't have it because here we have an open circle, right? So the farthest left I could go is a, and the farthest right I could go is c, and notice how I'm going to close it because I do have that x value of c. For the range, how far low can I go? What's my lowest y value? My lowest y value is b, and my highest y value is d. And notice how I'm closing it. Right? Here, oh, I should have mentioned, maybe I should have put this as well. Let this be like, oh, sorry. Make this like E or something, and make this F. Because now we could actually describe the idea of when it's increasing and decreasing. So notice that it increases from, let's say, A to E, right? From here to here, from here to this part over here, from A to E, the graph is increasing from A to E. From E to F, the graph is decreasing. And then from F to C, our x value F to C, it increases again. Increases from F to C. Okay. And yeah, that's the idea for this graph. Okay, let's do a better smiley face. Right. Here, pause the video and try this one on your own. What would be domain, range, and describe the function, whether it's increasing, decreasing, or constant. Right. So let's see. What is the domain of this graph? It would be from -5 to +5. Right? The farthest left I could go on the x-axis is -5, and the farthest right I could go on the x-axis is +5. And notice that because these circles are closed, I'm going to show it with a bracket. What about for the range? Notice that the lowest y value I can go is -4, and the highest y value I can go is +1. Notice I have these values, right? And then what can we say, what is happening between -5, x is -5, and x is 0, right? From here to here, you could say it increases from -5 to 0. It's constant from 0 to 2. And it's decreasing and then decreases from 2 to 5. Okay. Okay. All right. Maybe, I think in class what I'll do is, if there's a confusion of why these aren't brackets, I think maybe there might be a confusion of why isn't it like this, right? Like, because here, notice that when we talk about domain, we're talking about whether we have it or not. But for the interval of whether it's increasing, notice that at the point -5, like if I have my pen here, right, at -5, it's neither increasing or decreasing at this point, or at this point, nothing is happening. When we talk about the interval over here, we're saying that in between -5 and 0, the graph is increasing, but not at the point of -5 and not at the point of 0. So that's why when we're talking about whether the graph is increasing or decreasing, we're going to always show parentheses. But with domain and range, we could have brackets or parentheses. Okay? I'll try and explain this further in class. All right? Is there anything else? Oh yeah, if you want, you could try this one on your own if you feel like you want to practice a little bit. And we'll go over this one in class, right? And what I'll do is I'll create a delta math, and part of the problem set number 2 will have these examples for you to practice. Okay, I hope you enjoyed the lesson. I'll see you in class.